transformations, we're looking at translation, reflection, and rotation. So we're starting with translation. All of these transformations are ways of moving a shape around while keeping it the same shape and size. Translation is moving it side to side or up and down. So left to right or up and down. Now you can see that this is triangle ABC, and they've asked you to translate it, and they've said by a vector of -3, 2. Now there's some different uses for the word vector, but let's say direction at the moment. Sometimes they'll just tell you move it 3 points to the right and 2 units up. But in this case, they've given it as a vector. But what this is saying is -3. You notice how this is in the x-coordinate position? This means on the x-axis, so horizontally, 3 units, and negative means towards the negative side, so left. And this 2 here in the y position means on the y direction, that is vertically, 2 units, and because it's positive, it's up. So this is how you can read the vector for where we want to move this. And your best strategy for transformations on a grid is to do the change, the transformation, to each vertex, each point. So A has to go 3 left, 2 up. 1, 2, 3, 1, 2. That will be our new A, and we label it A because they said draw an image of the triangle ABC. But to be really perfect, because it's not the same A, we put a little apostrophe, which means basically new A, or the changed A. Then we do the same to the next point. So point C has to go 3 units left, 1, 2, 3, and 2 units up. And you can see that it ends up in the same relationship space to A. And that's going to be C with a little apostrophe. Now, if we're feeling clever, we can work out where B goes just from where A and C are. It's going to have to be there. B with a little apostrophe to say it's changed. But if we are getting anything wrong or if we're all confused, do this with B as well. 3 units left, 1, 2, 3, 2 units up. And then, preferably with a ruler or a straight edge, you finish drawing your shape. So that is translation. It's the same shape, we've just moved it around on the grid. The next thing we have to be able to do is reflection. And in reflection, they'll tell you where they want you to reflect it. Sometimes they'll say reflect it around or in the y-axis or the x-axis. Here, they've given us a line, and the line is behaving like a mirror. So again, your best strategy for reflecting is to deal with each vertex separately and then create your shape. So this one here has 1, 2, 3, 4, 5, 6 vertices. Now you don't have to draw the lines that I'm about to do in green, but I'm going to draw them to show you what I do. For every vertex, go straight towards the mirror line. And when I say straight towards the mirror line, I mean at 90 degrees to it. So if I put my protractor on the mirror line, 90 degrees is there. From this point to the mirror line, it's 90 degrees. And keep going the same distance on the other side of the mirror line. That is my first point of this shape. Now you don't have to keep drawing all these green lines. 90 degrees straight towards the mirror line, that was 3 units. 3 units straight out. Oops, I switched colours. That's the second point. Now some people are really good at spatial reasoning and awareness and could draw this reflected straight off the bat. Some people need to get more points. This one here, 2 units to get to the mirror line, 2 units to get out. There's that point. Some people are going to be able to, with a ruler, build the shape with just that much information. But if you find you're not sure, do more points. There's no shame in doing all of the vertices of the shape to make sure you know exactly how to reflect it. And especially with harder ones, it's a really good idea. Sometimes points are touching the mirror, and so that point stays exactly where it is. This point reflects to here, this point to here, this point, 1, 2 is going to come to there, this point comes to there, this point to there, and then you should have enough points that you can mirror image what's happening. Sorry about not using a ruler, I'm trying to have a bit of a faster video. Sometimes we don't have a vertical or horizontal line, we've got a mirror image across like this. Let's do letter D. We've got one touching, that point is going to stay touching. We still go from each vertex straight towards the mirror line and exactly that distance straight through. So this point ends up here. This point, straight to the mirror line, straight through, it ends up there. It can help to draw parts of the shape as you get the points in so you don't get confused. This point, one full diagonal square away, it's going to go to there. And you can see that this line goes back to that point, so this line goes back to that point. So just being careful with your reasoning. This one here, a full diagonal square and half of one and a full diagonal square. This point goes straight to that one, this point goes straight to that one. And then we might be at the stage where we can confidently draw the reflected shape. Sometimes shapes overlap on the mirror line, and that means your shape that you draw will overlap on the mirror line as well. If you're not sure, take every single point. So this point goes to the mirror line and 1 point out, unit out. This point goes to the mirror line and 1 unit out. Build your shape point by point if you need to. And the last one is rotation. And rotation is as if we had a shape where it is and we pin it down at a particular point. This is point C, and it says rotate clockwise by 90 degrees, and we keep point C where it is and go clockwise by 90 degrees and we'll get a transformed shape. Now this one again, it's a really good idea to do point by point. The pin is pinning this one down, so point C stays there. This point, again, the thinking is you go straight from that point to C. I know it's a bit hard to see on this one. You go straight from that point to C, and then 90 degrees, because that's what they asked us to do, which is obviously given by a grid square, which is nice and easy, clockwise, and I want to be that same distance out from C. This point ends up here. Try to get just a couple of points and then build your shape. So this point here, straight to C, 90 degrees clockwise, that point's going to end up there. Chances are from there you can draw your shape, but if not, get more points. Sometimes C isn't in the shape, and that means every point you're going to go straight to C, and that says 180 degrees, so 180 degrees around from that, and that was one diagonal. We want one diagonal. This point ends up here. This point here goes straight to C, 3 units, 180 degrees around, 3 units, that point ends up there. Were those 2 points touching? Yes, they were. These 2 points should be touching. The next point along from this one was that. Go straight to C. That was 1, 2, 3 diagonals. 180 degrees means keep going through there. 1, 2, 3 diagonals. That point ends up here. Once you've got maybe 3 points, this one, this one, this one, you can probably work out the rest of your shape. So it's about working out each point and how they're related to each other. Some people will need fewer points, some people will need more, and that's okay.